Hello and welcome to Teach Up, where we train you to do well on the AP Calculus test and to do it fast. Today we will evaluate the limit as x approaches infinity of the natural log of x plus 6 divided by the log base 3 of x. To know how this function will behave as we get closer to infinity, we need to recall what the graph of the basic function looks like. So the basic function here is just a log of x, and it doesn't matter what the base is. So here the log base a of x, where the base is any positive number that is not 1. So as we can see here, we can just notice that as we're getting closer to positive infinity on the x-axis, the graph itself is getting closer to positive infinity. So that means the numerator here is going to be positive infinity and the denominator is also going to be positive infinity because the behavior stays the same no matter what base you have. You may be wondering, well, what about this plus 6 that we have in the argument in the numerator? Well, that 6 doesn't really change anything as we're getting closer to infinity. Adding a constant is really not going to do anything to positive infinity, so we can just completely ignore that. So then we have this infinity over infinity indeterminate form. And this is one of the forms that allows us to use L'Hopital's rule. In the past, we've used the 0 over 0 indeterminate form, but this form also tells us, given all of the other conditions that are met, that we can find the limit we're looking for by taking the limit of the derivative of the numerator divided by the derivative of the denominator. Here, the numerator is going to have a derivative of 1 over x plus 6, and the denominator has a derivative of 1 over x times 1 over the natural log of 3, and that is because of this base of 3. So let's go ahead and simplify this. So I'm going to scroll down a little bit. This is equal to the limit as x approaches infinity of x over x plus 6 multiplied by the natural log of 3. Now, the natural log of 3 is a constant, a real number, so I'm just going to go ahead and pull it out of the limit and take a look at what else I get. The limit as x approaches infinity of x over x plus 6. Again, as we get closer to infinity, x is just going to be getting closer to infinity, and x plus 6 is going to be infinity. Again, we have infinity over infinity, which means we can use L'Hopital's rule a second time. So this is going to equal to the natural log of 3 times the limit as x approaches infinity of the derivative of x, which is 1, over the derivative of x plus 6, which is also 1. So here we have a derivative of we have a limit of 1. So the limit as x approaches infinity of 1 is just 1. It's a constant function, so it will not change. So this is going to be equal to the natural log of 3, which is this answer here, D.